I want to take a look now at how a graph and a input-output table are related, how one can create the other one. Now we're going to start off, I'm going to go into my statistics mode here and go into my editor where I've already put in a few input and output pairs. I've got in L1 are the X values, and straight across them in L2 are the corresponding Y values. First thing I want to look at is a graph of these. I'm going to go over here to Zoom Standard, and there the calculator is going to give me my input and output pairs, my ordered pairs, as represented as dots on the graph. Now I might want to do a little bit, move my arrow, my pointer up, and see if I can zoom in one more time and get a better look at some of these ordered pairs. And I can actually hit my trace button, and the calculator will read off for me the value of the ordered pair. Alright, so my first ordered pair is the ordered pair 0, 3. The next ordered pair is the ordered pair 0.54, and then we have the 1, 5, the 1.56, and so on. And as you can see, those ordered pairs are corresponding to the X and Y values that you saw on that input table. So we can literally see how X and Y values are being graphed one ordered pair at a time and then showing up on this table. Okay, now our rule, the rule that I used to get this was the rule 2x plus 3. That's what is generating those ordered pairs. Now if I go back and turn that graph on, when I graph that line, you can see that every ordered pair is on the line, and therefore the line actually consists of an infinite number of ordered pairs. If I turn this view on, we can see at the top here the rule, at the bottom the ordered pairs that it's creating. For example, here where you put in the 4, you give 4 times 2 is 8 plus 3, there's where your 11 comes from, and here's the graph. Now this table isn't the same one I showed you. This one's being generated automatically by the computer. So if we go and we look at the automatically generated table, we can look down it and see that these points, one after another, are ordered pairs that are a part of the graph. So that's basically the connection between the graph and the ordered pairs. As a matter of fact, if we go and look at the graph itself, we could go up here and turn off the statistics portion of this graph, get those little dots off the graph, and just look at the graph itself, and there it is without the ordered pairs. Now if we hit trace, what that will do is move us around the graph, not giving us the perfect whole number values before, but giving us basically just decimal round off type numbers. But as we move down this graph, we can see that one after another we've got ordered pair after ordered pair after ordered pair, and that is basically what makes up this graph, are these repeated, these multiple, these unlimited number of ordered pairs. It's how this graph is actually generated. So as you can see, any ordered pair is a point on the graph. All the points on the graph are ordered pairs, and given enough ordered pairs, you can actually do a pretty decent job of graphing an equation.